What's really interesting about this approach is like I use this all the time, and I do it in slightly different flavors. But the idea is like the more assumptions that you can bake in ahead of time, and the more correct your design is, the more likely it is that your implementation will be correct. It's 37% the dumb zone detection. Generally, the less context you use, that's a smart zone. So once you start hitting like 40, 50, 70, 80, 90%, it's not that you're in the dumb zone, you're just being less efficient with answering questions.
Yeah, you're getting worse. If your problem is really easy, you can solve things in the dumb zone. The harder your problem is, the more you want to optimize for doing most of the work in the smart part of the context window. By the way, here's the learning test output that got added. So we actually have like the observed output from the test, which shows exactly like how the state machine of the internal Claude thing behaves when we feed additional messages into it. So this is super valuable. This did exactly what I wanted.
Hello, everyone. I'm Vaibhav. I'm one of the co-hosts of AI That Works. Every Tuesday, Dexter and I get together, and we like to go talk about AI stuff that kind of works. I work on BAML, which is a programming language for building AI pipelines. And this is my co-host, Dexter, who works on Human Layer and has been known for context engineering.
Amazing. Incredible intro. And today, we are going to do a very fun segment that we do roughly once a month called No Vibes Allowed, where we are going to put a bunch of this stuff into practice, and we are just going to live stream me and Vaibhav collaborating on a feature in one or both of our tools that we work on every day. So you're going to get a peek under the hood of how we build using all this stuff, putting it all into practice. So today, I guess we can get into it. We are going to be building. If you've seen other live streams, we use a tool called Riptide, which is the working title for the Human Layer IDE, name TBD. But if you hear us say Riptide or Code Layer, that is what we were talking about. So I'm going to pull this open. Riptide is basically a manager workflow thing. Just to walk you through kind of what we're doing here, I'm just going to launch a Claude Code session here. And essentially what you're going to see is a demo of what we're going to build today. So I can say this, I can say, bash sleep 10. And then the issue that we have with this is I cannot actually, if I want to send another message, when you're done sleep again, there's no way to queue this. I can interrupt the model and send another message, which will cause this like interruption thing to flow through the tool call pipeline. But what we really want is the ability to queue a message. Does that sound right, Vaibhav?
Exactly. Because one of the most annoying things that I love to do in other agentic systems is I press enter and it waits until it's done and then queues it on.
Yep. And we've actually done an episode before about interruptible agents and how to build message queuing and how to decide when and how to interrupt and what to provide in the interruption message, right?
Exactly. Because interruptions are slightly different than queuing, but the technology stack is the same.
Yep. So I'm just going to get this ready real quick. I'm just going to make sure we have the latest main pulled. Okay, we're there. And then basically what I've done is to prep for this episode is I've actually done the early parts of the workflow. So we've talked about a little bit about kind of the workflow steps. And I'm actually going to pull. So we have this long workflow of going from research questions through to research, through to design. We're going to walk through this. We've walked through this on previous episodes as well. Since the last time we did one of these episodes, we kind of only made it through to the structure outline and the planning phase. We didn't actually ship any code. I've actually gone ahead and gone through to the design discussion. I haven't looked at it yet, but just this morning I kicked off a job. So if we come into Riptide, we've created our research questions. And you can come see, here's the ticket that I wrote, which has a couple comments between me and Kyle of like, hey, we want to support message queuing using the Claude Agent SDK. And so those questions were used to create a large research doc, which kind of outlines how we use the async prompting, how the state machine for sessions works, the states in which we allow you to send a new message, the interrupt flow, the continue session flow, all this kind of stuff. Vaibhav, do you want to go a little bit deeper on any of this stuff? Or like you're kind of familiar with the tool and the architecture, so.
Yeah, so I'll hop into the doc really fast just to catch people up on what we're going to be doing.
Yeah.
I'm at the bottom, Dexter.
Yep, I got you.
So this is the ID. And today what the ID allows us to do is you can press this button and you can hit interrupt while the process is happening. That's the only way that you can actually go do things. I think the default that we're trying to go do is make it so the default here changes from interrupt into queue. And of course, you should still be allowed to interrupt as before.
Yep.
But by default, when you press enter, it should just add the message on and wait until the system is done and then proceed onwards. This isn't that hard, especially because we're living in a single process machine. That makes life much easier. We're not doing a distributed system. So some of the race condition stuff is kind of handled for us for free, which is kind of nice. And then the only other question to ask is, how do we make it so that it's very easy to modify the queued messages? How are we allowed to queue multiple messages at once? Do they all get concatenated together as a single message? Like, what happens in the queuing behavior there? But otherwise, I think this should hopefully be a straightforward task, and hopefully people can get a pretty good idea of how we would technically, what the difference is technically between an interrupt and a queue, and we'll get to talk about some technical concepts as well.
Yep. And just to kind of demo how this works, maybe briefly in the Claude Code CLI itself, I can launch Claude here. I could say bash sleep 10, and then I can say when you're done, sleep again.
Yeah.
And so that queues the message. Yeah, this is the behavior we want to implement. The Claude SDK supports it, and we've done some research. And I even had one thing that's really fun is you can actually have Claude. I think one of these actually did like a rip grep through the SDK source code itself.
To go find it.
To go find actually just like the types for, let's see. Yeah, Claude Agent SDK. So we looked in node modules and actually like went through and found the types and the interfaces, and some of the code inside Claude is minified, but you can at least explore the types itself.
Yeah. Riptide is not open source as of right now, but it's you can go ahead and actively sign up for the waitlist and then get access to it pretty easily. Yes. Especially for people on the show.
Yes. So I've gone and created our design discussion, which was just a session here. Use the create design discussion skill, went through and did some analysis, and then we've built this design discussion doc. So I haven't looked at this yet, but one thing I want to do before we look at this is I know that we talked a lot about learning tests and about how do you create feedback for Claude to understand, especially libraries which are closed source, like the Claude Code SDK. The wrapper parts are open source, but the binary itself is not. So we really, really like to build some what I call learning tests here, which let's see. Let's find one here. So this is an example where we're actually going to run the Claude Agent SDK and run it in bypass permissions and like make some assertions about how, like, what sorts of messages in JSON come out of this. That make sense?
Yep.
So I've actually primed it as well in another session of just like, cool, read the design discussion and then basically like come up with a proposal for proving how this stuff works. And so one thing that we found was like we do have a streaming input test, but it uses a timeout and it doesn't actually test that you can like queue a message. So I think this is probably the right one. So I'm just going to come on here and can you just create exactly one test where the model has a tool approval for the bash tool and ask it to do bash sleep 10 and then immediately queue another message that says, when you're done, sleep again. We'll actually do bash sleep 3 just so the test runs more quickly. But let's get this running and let's get enough example code that you're able to update the design doc with any findings with how the SDK actually behaves. Does that make sense?
Yeah. And again, these models are really good at pattern recognition. So really what Dexter you're doing here is you've built a pattern in your repo that says we use this opaque tool called Claude Code that doesn't really document very well its behavior. So in order to deal with that, we have a pattern for how to explore the SDK in the form of learning tests. We talked about this in agentic back pressure.
Yep.
Like either last episode, 2 episodes back. And then now that the model can just replicate, it doesn't have to innovate anything. It's literally replicating its existing learning test. And most importantly, you're using the same terminology there called learning tests. Yep. So like you're using the same word, so it knows exactly what to do. It replicates a pattern really fast. The harness knows what to make happen. So then what's happening now is if it is able to go and confirm something about the queuing behavior, it should be able to give you all the design information you need on your end to make that behave properly.
Right. And this is kind of like one of the challenges with this whole like planning workflow. And we talked about this in the back pressure episode, but like what happens if you have some assumption because you read the docs, but the docs were wrong or misleading, or you misunderstood them, or Claude misunderstood them? Like, you're not going to find that out till you're like 2 phases into your implementation. And then you're going to have to go rewind and redo all of this work. So this is kind of an opportunity to jump back and kind of do some, like, there's a couple flavors. Like, there's research from code, there's research from the web, and then there's like research from like proofs. I call them proofs or learning tests or whatever you want, but there's like multiple different ways to build up knowledge about what is true about the world, whether it's my code base or external things, before we decide how we're going to approach building something. Yeah.
What's really interesting about this approach is, like, I use this all the time, and I do it in slightly different flavors. But the idea is, like, the more assumptions that you can bake in ahead of time and the more correct your design is, the more likely it is that your implementation will be correct.
Exactly. And you want to minimize the chance of surprises, because then you're like deep in 1,000 lines of code changes and you have to try to like re-navigate your way out of it.
Exactly. And now imagine a scenario, and there's this, I mean, Amazon's famous for leadership principles, but like, and I know they're a meme almost in a lot of scenarios for people that know them, but there is one that I personally abide by really well, which is just that great leaders are right a lot. And the fundamental matter is, like, the way that you get right a lot is you make really good decisions up front. And when you're right, it's not that you're good because you're right. It's that when you are right, you move so much faster than any other competition because you don't have to go back and fix your mistakes. So what ends up happening in coding is the less mistakes you make, even though it feels slower, actually the way faster that you move, because you're not backtracking. And backtracking is the hardest thing to go do. Even though now in Cloud Code you can rewrite the whole system from scratch, if you're going to make a mistake, you will literally just move way slower. And especially if you make an architectural mistake, then you'll move even slower. And if you detect that mistake 5 days later after you already merged it, then you're still going to be even make even more mistakes along the way. Like, you really want to minimize the chance of mistakes, and you want to be technically correct whenever possible.
Yeah, it's like decisions take not a lot of time and have a lot of impact, whereas execution can take a lot of time. And so if you waste time in execution when you could have just made better decisions, then you're not going to make as much progress as quickly.
Exactly. So like, that's why I think most people like this learning test is going to be phenomenal, because once we know exactly how to use the Cloud Code SDK for queuing, and it's confirmed with a test that it works that way, the design doc here is trivial.
Yep. Well, so I will say, you mentioned this is not a distributed system. This really is a distributed system. So the architecture here is like, you're entering a form in a UI, which then stores things in an API, which has a database of like queued messages. And then the daemon is actually like fetching those and then relaying them down to Cloud Code, multiple Cloud Code sessions.
Yes.
So we will have some interesting infrastructure stuff to go through here.
But it's not, you don't have the same race conditions that you have across network packets.
That's true. Okay.
That's what I mean. Like networks, packets coming in and out of order in various ways. Like, it's basically, the order of delay here is like sub a mil. It should be like 1 or 2 milliseconds.
Yep.
Which gets rid of a lot of like the human press enter and oops, I pressed enter again before the message came back to me and round trip what the state of the world was.
Yep. So this is going to keep working while this is running. We can pop back to our kind of main design. I'm going to archive that one. We can pop back to our kind of main design discussion and just start reading this. And I'm actually going to create a anyone can view link, and I'm going to send this to you, Vaibhav, quickly in the chat if you want to kind of like skim it on your own.
Perfect. And then while we're here, do people have questions? Have other people built queuing or interrupts or other workflows along the way? I know, Josh, you asked a question. Is 37% the dumb zone detection? Generally, the less context you use, that's a smart zone. So once you start hitting like 40, 50, 70, 80, 90%, it's not that you're in the dumb zone. You're just being less efficient with answering questions.
Yeah, you're getting worse. If your problem is really easy, you can solve things in the dumb zone. The harder your problem is, the more you want to optimize for doing most of the work in the smart part of the context window.
Exactly. That's like the best way to frame it. All right, we're going to be a little silent while we go read.
Yes.
But I will maybe perhaps entertain people while you go read this lecture really quickly. Saying, you're asking if Riptide is like Cloud Code. I think Riptide is a more analogous to a harness around Cloud Code. Because if you think of Cloud Code as a way of doing work, Riptide is more like a workflow. on top of Cloud Code. It's slightly more opinionated in the fact that it makes you do a little bit more like thinking up front and helps you discuss and go back and forth with the system. Whereas typically with Cloud Code, even in plan mode, the default workflow is like when you do Cloud Code planning, it produces a plan, and that's often it. I see most people just hit straight enter, clear context, go onward. And that's because most people don't actually read the plan in detail because it's not designed to be read in detail. Like, let's be real, there's a reason we don't use less to read the less command and grep to go read our terminal. No, very, very few people read in like Vim. Most people like to open NeoVim or like some other IDE to go read code because UIs are nice. And it just helps with reading faster.
What I'm doing when I'm going through this doc, right, is I'm like making sure it understands what the end state is of like, okay, yes, we need to show a message in the UI. They're delivered in order. The daemon picks them up. The existing flow works as is. I would also add one thing here, which is like for desired end state, we want to make the default action when you command enter while the session is running to queue message. And so there's a new button for queue message, and then there's another button that will be persistent for interrupt. And so rather than a single interrupt and send button, while the session is running, we'll have those two buttons. So let's highlight that in the desired end state and reflect that throughout the doc.
And again, this thing wouldn't have been caught unless Dexter was actually reading the doc, which is why sadly that's why he's got to be silent for some time, because like there's no way to talk and read at the same time.
I could talk through kind of like open in my like just basically like thinking out loud of how I'm like reading this and what I'm looking for. Like we have the desired end state, and then the next level down is patterns to follow, right? We talked about how AI models are really, really good at finding and understanding and like matching the patterns that already exist in your code base. And so one of the reasons I've built this into my design doc system is basically because I want to get a brain dump of what the model is thinking and what it has seen. Because if the model goes and starts coding, you might catch it in the middle of coding, like, oh, you picked up the wrong pattern. Now, our code base is only a couple months old, so it's got mostly good patterns. But when we work with people who have very old code base, have been around for 10 years and have 5 different ways of doing something like, let's say, an atomic SQL update, we want to make sure that we're doing those inserts correctly.
Exactly. And like the idea is like, and really it's like, look, one bad grep in your Cloud Code, like code research system, is all it takes for your system to be bad. Yep. Like that, great leaders make right decisions. That's one bad grep and you've made the wrong decision. And if you're not even reading it, let's be real, we don't read all the code AI generates. That's just slop that gets amplified over and over and over again. And that also has consequences because next time the odds of getting that bad grep go up. Because like it's like, oh, you just reinforced the pattern in a very modern way in a more recent time frame saying that that pattern was acceptable. It's like, of course I'll do it again.
Your code base will always regress to the average of the best pattern and the worst pattern in the code base. It will just have more of the bad ones and also maybe sometimes pick up more of the good ones, but it will just
I would actually say your code base would probably converge on the most common patterns in your code base. It converges to the mode more so than anything else.
Yeah.
Because like whatever it finds more often is what it works. Alvaro, you've got a great question. How do you handle when the agent is constantly getting into issues? I've been asking it to update its progress and blockers in an implementation summary file, but is there a point where I try a different approach? Do you persist these progress files somewhere after you're done with the task? So one of the other nice things about Riptide is you do get all these files preserved in nice little like shareable links. Like for example, Dexter just shared that with me. Well, I can tell you our workflow. I don't actually check in these plan files everywhere into my repo. Plan files are throwaway. Research files are throwaway. They're like task specific. It's very similar to like if any of you have ever worked in a large company, like for example, like when I worked at Google, we wrote design docs all the time, but we also never referred back to design docs after the implementation. And that's
the code base. As soon as it's shipped, the code is the new source of truth.
Exactly. So every time you want to go learn what the system does, like sure, maybe you'll give a design doc to a new hire that came in to understand like conceptually, but I would never tell a new hire to be like, this design doc is what is true.
Yeah.
If you want to know the truth, read the code.
So, and that's why we always generate the research on the fly as well. We don't really rely on like code based context, high level.
And you definitely don't want to preserve. It's just so cheap and like time wise and money wise to go determine the research that it's literally not worth storing this information.
Yep. So here's the By the
Go
way,
ahead.
here's the learning test output that got added. So we actually have like the observed output from the test, which shows exactly like how the state machine of the internal Claude thing behaves when we feed additional messages into it. So this is super valuable. This did exactly what I wanted.
Yeah. Josh, you've got a question. Can you specify new patterns? For example, let's say I'm creating a V2 API that uses a different pattern than V1 API. How can I say use the new V2 pattern? Well, that's really easy. You just tell it, use the new V2 pattern. And like Claude Code, when it does the research, like as a part of your ticket definition or your original task that you do before performing the research, you just say, we strongly prefer V2 over V1. Then you let it discover the research, produce the design doc. Then you read the design doc to confirm that it made that critical design decision of your choice, saying it better be using V2, not V1. And it might still reference V1 as like an older pattern, but it still says, hey, V2 is the more consistent pattern that we want to go use. But it's twofold. It's one about telling it to do it, and two about actually just verifying that it did do it. Again, it's very similar to hiring a junior engineer. Like when you're first implementing a design doc, you can have a design doc that you wrote as a more senior engineer. You hand it off to a junior engineer. They're almost definitely going to mess it up somehow. Like almost definitely. And that's not because they're bad. It's probably because you missed something in the design doc, or you had some small thing that was slightly off, or you had a baked in assumption that was in your head that you didn't feel necessary to write it down. So how do you validate that system? Well, you go read their system. Like whatever they implemented, you go read and validate that it matches the doc, at least for the most critical parts.
Well, and the inverse is also true, right? So like Kyle, my CTO, is like kind of the end all owner of this code base. And I actually don't know the answer to like in this code base, you could consider me junior to Kyle in terms of like ownership and like opinions and like having the last word on how this stuff is built to make it the most maintainable. I actually don't know the right trade-offs between option A and option C. So I'm just going to take the recommendation, but if we weren't live on a podcast, I would actually just like copy the link to this and send it to him. Actually, I think we get them auto linked to the linear issue, but I would just copy the link to this and send it to him and ask him to like tell me which of these options is correct, or if we want to actually do like an option D that's not even surfaced.
What are the options here?
So the option one is basically we're going to add a new collection watching the conversation events table, which is like, it's a little bit over. So conversation events powers all of the events in this stream.
Got it.
So it's the user messages that the user enters merged with all the events we got from the Claude SDK. So we already kind of use it. I'm actually like, can you add more detail on the trade-off?
What's option B?
Option B is a terrible idea. It's like putting a queued messages JSON B array, which makes it really hard to do it.
That's incorrect.
It's going to be really hard to do atomic updates on that one.
Yeah, exactly. Yeah, that's a no-go. That's like clearly a no-go.
Option C is basically create a new table and a new collection. I think like option C is a little cleaner / safer, but option A seems simpler. I just don't know what the consequences will be of overloading that table even further, since it's really meant to be a like display logic for what shows up in the session.
Well, in some ways, queue messages actually are good for display logic, because they are basically also going to be displayed. And the state of the message is going to be displayed. If you remember back to the queue to interrupt episode, I actually think that's the right way to think about it. There's a single source of truth.
Yeah, my take is that we might want a message queue table, because that'll make it also easier to show in the UI. And then we would just only show queued messages matching some filter that like they would get flagged as once they were delivered and acknowledged. And we have the explicit lifecycle. So I'm leaning towards C, but add a little bit more detail and we'll come back to that one.
Oh, I meant like keep it in the same. I actually meant keep it in the original one, and then just basically make all edits also like incremental on top of it. So, and then whenever you process the next event, you pop off all the queued events and you process them all together.
Yeah, I mean, I think we can do that with option A or C. So I'm gonna just actually fire that off, and it's gonna go do some thinking and searching. And while that's happening, I'm gonna come to question 2.
Okay, and someone's got another question really fast. Is there a way in Human Layer to specify this? There's nothing specific. I mean, Human Layer is more of a process. Like Riptide's more of a process of how you use Claude Code. Then like, hey, there's something, and the process itself is highly opinionated, but it's still flexible enough to do the thing you need to go do. So like if I'm Dexter, you build the product, like at least I can I would personally hate it if they started opinionating very specific things, like the way my code should be structured.
Oh yeah, no, we won't do that. The whole point
Yeah,
is like, I don't want to make decisions about your code base. You should not want Claude or Codex or any agent to make decisions about your code base. The idea of this design discussion doc is that like it forces the human to do the high stakes decision making about the architecture of the system. But everything up until this point is something that AI is very good at automating, of going and reading 100,000 lines of code and figuring out which ones
exactly.
are relevant and asking really good like architecture questions. But you, the human, are in the driver's seat. And again, like we don't even have to answer option A or option B for this question. We can even say, oh, actually, I want to do option C, or like kind of re-steer the whole thing. But this is your chance to, before the model starts working and coding or even building a plan, like do brain surgery on the model and like update the patterns it's going to follow and the approaches it's going to take before we go further down this process to the structure and how we're going to break this down into tasks, and then the actual code we're going to write, and then actually going and shipping it.
So for context, one of the things that I've been doing is we've been reworking our proto system to be a lot more robust so that you can construct more arbitrary types and do more interesting things in BAML. And part of that was doing a whole migration on basically redefining our proto. And what that really meant was some of our types, like media types and like prompt types, aren't available to you inside the language of your choice. They are available in a slightly fuzzy way. We're making it much more wire-friendly and relatable. So I actually went through, and this was exactly what this was. We had a V1 migration, we had a V1 version of the proto and a V2 version of the proto. And there's two ways that people can approach this. One way is you have the same code base and you kind of make it so you kind of keep both alive together. That, Josh, is the problem you're probably running into, is like, how do you tell the model that you need to keep one thing alive or not? Well, the way that we found best worked to actually solve this, again, because writing cheap code is so cheap, they're actually just creating a whole new folder at a new top level and almost a new package, and just writing all the code in the new package. And then anytime you have code that's in the old package that needs to be migrated over, you just migrate it over. And it's so cheap to go implement this that it doesn't matter. And then I just went through the approach, and I basically just went through and I did the research questions. And it came up with a bunch of questions along the way about like what it needs to go answer. Then it went and produced the doc for what it needs to go do and understand the existing type system, and actually like pulled out everything perfectly out of here. And once I did that, then I spent the 90% of my time basically just iterating on this one file over and over and over again until it produced a really good design doc. And you can actually see, like, once it produced a design doc and I iterated on this for quite some time, the chat log is pretty big. Then I actually did another thing, which is it produced a structured outline for what I'm actually going to go code. And the problem is this is a massive refactor, so it has massive consequences across the whole code base, and a lot of consequences across multiple languages.
You have to be really thoughtful about the order you make the changes in, basically, right?
Not just that, but I need it to be complete, and I really can't have any bugs. Because if I have bugs, like testing this is like really freaking hard, because I'm basically redoing the whole like serialization layer. Mm-hmm. So what I do is once I produce the layer, not only do I read this structured outline really carefully, but then I do this really silly thing, which is I start like multiple prompts that do this. What's inconsistent / missing for the structured outline? And I just have the model rip on it, and I discuss design decisions. And then after that happens, I ask it again. What's missing inconsistent for the structured outline? I just keep on doing that.
You're basically Ralph Wigguming your structure outline. You're just throwing more tokens at the problem and tell it to think more, and it's giving you a more complete result.
Well, no, it poses design decisions to me at every single stage of like, oh, here's what's bad, here's what's good, here's what's bad, here's what's good. And then I actually think about each of these individually. Yep. And then I update the structured outline. And then I produce the plan. And guess what? Once I did this, I actually one-shot the whole implementation. I'd never have to go edit this code again. And this was like, maybe I can pull up the PR just to show you guys like what code was this. 17,000 lines of code added, 13,000 times removed.
Wow.
This was roughly what this was. But it one-shot the whole thing.
That's sick. Did you check in between the phases? Like, did you do any verification, or you just have it run the test at the end of each phase?
I just had it run the test, and it went through. And then just to be very, very transparent, CodeRabbit, which is our CI, which is the thing that we use for validation, actually found a bunch of bugs. And like, I don't know if I vouch for CodeRabbit specifically. All these tools are roughly the same and pretty good, but like CodeRabbit's good enough for us, and it found some bugs. we addressed them. I did a bunch more pushes, and then I merged it. But like end-to-end time, you just look at my commit time because this will give you a better idea. Like when did I make the first commit of how many commits there are? So there are like roughly 18 commits on making this work. And this was 2 weeks ago, all the way to 5 days ago. So I made I got WASM working a while ago, and then I slowly made the whole prototype buffer stuff. So like this is roughly the workflow. It's just more about like really quickly iterating in a really good way.
That was a great detour while I'm over here coaching
Keep
Claude.
reading.
Yeah. So for question one, we remember I asked it to add a lot more detail, and it kind of like figured out, okay, this is kind of noisy. There's no host ID column. There's a bunch of stuff. So I actually like steered it towards option 3, and the cons are like more infrastructure, dual write, and host ID. Like this is actually nice. This is going to make the system easier to maintain and debug. So I'm going to proceed with option C. For question 2, it's just asking about like how do we pass this in, and it's like one of them is proven to work by the learning test. So I'm like, cool, we're going to do that one. For the API endpoint, I want to extend the continue endpoint because when I send I don't want a separate endpoint for queuing. I just like want an endpoint that is like send a message and let the API figure out the business logic.
And then you just give it like a Boolean of like a continue or interrupt, like queue or interrupt.
Well, we already have an interrupt endpoint. And so it was like, okay, do we extend the interrupt endpoint? Do we extend the continue endpoint? Or do we add a new endpoint? And I'm like, I like the idea of like, cool, there's just a thing to send a message. And
I would unify all 3 of them. I would literally just unify all 3 of them to a single message that comes in with a Boolean. That says like, that comes in with like a state of like what kind of method you have. And like one of the states is auto. That actually would, I think that'll actually simplify your logic. Because again, when you're designing the system, what do I think about? What I think about is like, what I want is I want the UI to be dumb. And the dumber that I make and this is also applicable to everyone building like a chat app on their website. The dumber your UI, the easier it is for you to consolidate state and business logic on the back end in your server side, which has a couple of benefits, which means that when you eventually make your backend agent friendly, and I believe everyone will eventually make their backends agent friendly, in that world, now you have a really nice world where because your front end is dumb, even the dumbest agent can use your backend without a mistake. Because the logic is consolidated in one place, not in 2. And like even here, like the front end is basically sending a request or a preference. It prefers that you queue. It prefers that you continue. It prefers that you interrupt. It prefers that you auto. But let's say like the backend has finished a message and you spent queue automatically becomes a continue on the back end. Or let's say you hit queue and there's some race condition in the back end for that reason. Continue automatically becomes queue.
Yep.
It's a preference on the UI side. So that's how you deal with race conditions in this world.
Yeah. So I've said basically we're going to pass an enum, which is like queue or continue or interrupt or auto. And basically if you try to continue while it's running, you'll get a 400. If you try to queue while it stops, you'll get a 400. But if you do auto, it will basically route it to the right behavior. I would actually not even do the 400. I would just make it do the right thing. Interesting.
By default. So that way if there's any lag, then you just like default to the best known state.
Just have a Boolean interrupt bool that determines whether we, instead of the enum. Yeah, I like that.
Because it's simpler, you know?
Yeah.
And like simplicity, I think, is key when designing these kinds of APIs because you're not really queuing. You're just pressing enter.
Yeah.
And it's just a question of do you press cancel and enter or just enter?
Yeah. Yep.
And again, the logic is keep your front end dumb. Keep your front end as dumb as possible.
Yep.
Russell, you asked a really good question. If engineering code is so cheap, why not build both or even all the options and test which one works better? Well, it is cheap, but it does still cost finite time and finite brain power. So let's say I could build all of them in parallel. I would still have to evaluate all of them in parallel. Instead, an alternative way to spend that same time is to build another feature in parallel to building this one. And that is a higher value prop than building one thing 7 different ways, especially if I know architecturally the right decision to make already. And I don't have to explore bad paths.
You're going to have to make that decision either way. Like which approach are we going to use? Yeah. And so like, yes, sometimes if I don't know what the right approach is, then maybe I will, like what we did here is we forked off and did a learning test because I'm like, I want to try a couple different approaches and find out which one actually works here. versus the versus just picking certain architectures and stuff.
Yeah.
And I'd rather review it at this stage, which is a shorter, 200 line artifact, than go have to review two versions of the same 1,000 line pull request and test
Exactly.
that code end to end. Like, if you really have no idea, then you should go figure that out by building little POCs or building prototypes. Or like one thing we do a lot is we use Storybook. Let me see if I have this in my history.
Yeah, the premise is just like, look, you have to do the work no matter what. It's just like, how early can you do the work? And the earlier that you can make the right decisions, the better. The less data you need.
So
You
another
basically
thing
want to
we'll do
make
for
decisions with the least amount of information possible.
Yeah. So another thing we'll do for like back pressure and like design up front is like, here's a bunch of like rich, complicated components that we were working on that like, instead of waiting until the implementation and building the whole feature end to end with each version of this, we actually just like, okay, for UI stuff that the agent's not really going to be able to have good like back pressure or like bring taste on it, we can actually do this in Storybook and kind of like carve off the parts of the decision making that we're going to do. Does that make sense? I don't think we've talked about this, Bob. We were going to do an episode on this as well.
Because like it's just, again, it's about moving decisions to making the fastest possible decision in the right system.
Yeah. Yep.
And Jens, you asked the question of like, did we cover where the docs live? Yes, they don't live anywhere. You delete the docs after you merge this in because it's pointless.
Yeah. And so technically, like, I can open this in my editor and it does exist on my file system and I can edit it here. But the idea is like, I have a ton of like go to archive tasks. I have a ton of archive tasks, and like these are all things that I've finished working on. And like, yeah, technically I could come look at these old docs, but you don't want to think about managing them. You kind of just want them once you're also done with them. Yeah.
Go back to traditional companies. Traditional companies have millions of design docs all over them. No one reads them, and that's okay.
Yeah.
Like we have survived in software. Exactly. Design docs are purely an execution concept. They're to make it so that you don't make mistakes by accident because you made some fundamental architectural decision that someone else could have known if they just read one sentence in your design doc. That's the purpose of all these docs, is to make sure that when Claude Code actually executes, it makes no mistakes.
Yeah, and it's just like it's so much easier to iterate on the design here of like, cool, we want a unified continue endpoint. We want 2 buttons in the UX. It's just like, okay, now I know I have high confidence that the agent's going to do what I want, and I didn't have to wait for it to start writing code and then have to try to re-steer it or start over or check out the code again, because it's just gonna it's dumped out its understanding, and we are aligned.
Dexter, how far do you think we can get in the implementation? How close are we?
We can certainly turn on the auto advance, and I can rip it through the next couple phases. Have you tried this yet, by the way?
I have. It's great. Okay. I auto advance through design discussions every single time. It's freaking pointless to do research with like a manual loop.
So this is going to keep updating the design discussion. Give me the Ralph
Wiggum loop that I want. I want to add that step. I have that iteration step that I do, which is like iterate on the structure. Because I do that every single time I create something really complicated. And I've had a 100% hit rate with that.
That's actually the next thing, is like the inverse of auto advance is like queue extra passes of just like, go through the research, vet every assumption, add more detail, find more things, fill in more gaps. And you can do that at every stage, is basically just like queue another round through it.
Yeah. I really like the message I have works really well. Literally just what's inconsistent / missing. And it works really freaking well. I'll let you finish reading this. There's like one more question. Brandon, you commented that your team has accumulated a lot of skills. I agree. You should probably prune the number of skills that your team is using to a minimum set that you can get away with. And the reason, and Dexter, I don't know your opinion, but the reason I personally recommend that is because your team probably can't even remember all the skills that you have checked into your repo. It's way easier to have 5 or to 7 skills that are phenomenal and being used all the time and actually being edited and maintained in your code base than it is to have like 70, of which all of them are one-hop used by each individual randomly in like totally different ways.
And this is how I think about all tools, actually, is like people want to just like give everybody everything and everybody figures stuff out and everybody's kind of going their own path. But like the things that give you compounding returns on engineering teams is like everybody is kind of using the same things and they're all iterating. Like every week your tooling gets a little bit better. And that's really, really hard if like you have 50 people and like 2 tools are being used by 3 people and 6 tools are being used by some other people. So it's like, I would even say like product manager, like the skills you build
It's
for your team are products, and a good PM goes and looks at their usage metrics, and they find the features that only like 10% of users are using, and they
and
remove them
kills
from
them.
the product. They
Yeah.
kill the features that are not getting massive adoption. And so I would focus on a small number of things that everybody uses, that everybody, I mean, not every, right? You may have some backend engineers who never use your front end skill, right? But like get good adoption on a small number of skills, because then you're like guaranteed that like, okay, this is going to become part of our culture. And the time we invest in making things better is actually going to pay off, versus like having 70 things and not knowing which one is going to help which people, and not knowing where to invest because you yeah.
Yeah. Prune. That is the magic word.
Cut scope, iterate, focus on a small number of skills. But
focus on your product, not on your engineering workflow. Like your engineering workflow, like learn from other people, leverage it, and like copy and paste. Don't reinvent. You will just move slower if you do. Just a question. How do we deal with bike shedding or irrelevant design discussions, like security stuff that comes up? So
is this human to human or human to agent?
I assume agent, like agents proposing like stupid things. I suspect that's because you're probably just not prompting it well. I've actually never had it come up with like arbitrary bullshit that doesn't matter when I'm doing like the workflow well. And that's because like it really depends if you're working in an existing code base or a new code base. In a new code base, it's actually very likely to come up with bullshit that doesn't matter. But in an existing code base, it really just follows the patterns that your code base has. So if you have like dumb unit tests that basically check like no ops and like things that don't need to be unit tested, Claude Code during the research phase will be like, I need to add unit tests for every little thing that I do, which is actually a drag, not a value add. If you're deliberate about what unit tests you add in, it will also pick up that, oh, we only unit test this kind of pattern. And this is the interface we need to unit test, not every interface underneath the sun. And I think that's really what it replicates. It replicates the patterns that you already have in your code base. And if you have no patterns in your code base, in that very beginning phase, like the greenfield phase, you have to replicate.
Yeah.
But 90% of code bases are not greenfield. And if they are, like, just you can just prompt it. You can just tell to ignore that concern. Yeah, exactly.
But even if you have a greenfield code base, it's going to become not greenfield within like 3 to 6 months. And then you're going to need to know how to do this, or you're going to have to throw it out and rewrite it from scratch, which like,
or like 1 week how you build at the rate that code gets written now.
Depending on how careful you are, yeah. I'm going to talk about quickly what's happening here. So this is building. So we talked about like basically like the design discussion is figuring out where we're going. The structure outline, how we do this, is basically like how do we get there? And so like the models by default tend to want to do what I call like horizontal planning, which is, sorry, I'm going to delete all of this, where it's like, okay, we're going to do the database, and then we're going to do the services layer, then we're going to do the front end, we're going to do the API, and then we're going to do the front end. And like before you know it, you're at the other side of 1,200 lines of code, and there's been nothing along the way for you to test. And so this is what I call horizontal planning. The models love freaking doing this. I don't know why. And so what I have found works really, really well, especially for larger features where like you want to kind of check in and make sure it's good along the way, is we do what's called vertical planning, where we will like take a slice and like mock the API and do a stub front end component. And then we actually build out the front end component on real data. And then we mock the services layer when we wire the API through. And then we do the database migrations. And then we add more everything up. We wire everything up. And then maybe here we add some like special like business logic stuff that is like the meat of the issue, but is like the same way you wouldn't write 1,200 lines of code and not check on it. You would at least run the tests in between phases, and you might spot check a couple things in between to make sure it's good. This is the art of vertical phases. And so the idea of the structure outline is like, instead of reading the entire plan with every code change, you want to just kind of review the approach that is being taken. And so this is going to surface some of the stuff from before, and then it's going to talk through. It's like, okay, we're going to make the schema and a message queue table. Then we're going to make the route and the collection. Then we're going to like queue messages in the prompt generator. And then we're going to do this unified continue endpoint. Okay, interesting. So the problem here is like, we're not going to be able to test this endpoint until the very end. Like,
I think that should be fine, though.
Well, so I would rather do the endpoint first, because then we can at least check in the database that messages were like inserted correctly. And then we'll do the actual logic that causes the Claude side. Because like you can't test this until you have a way to send the messages in. So why would we build the daemon side before we build the API side?
Oh, interesting. I see why you do that. Okay.
Because like basically like this is a lot of complicated stuff. We're making new database tables, we're making new contracts. I want to be able to click something in the UI and just go look that a thing was inserted into the database at least. And by I mean I'm going to basically like click the thing and then like Claude's going to go check what's in the database in my dev database on my local build. And then we'll go and actually wire it through to the other side.
Yeah. And again, that's just like preference for what for other people. Like, why are we doing this? Well, Dexter said a very good reason. He's like, I want to test sooner, not later. And the sooner that you can test the system, the better it is. And if you have no way to test something, then what Dexter is basically betting on is not the fact that like his design doc is right or wrong. He's just reducing the probability that he has to backtrack.
Yes. You want to optimize for being able to finding surprises and finding incorrect things as early in the process as possible. So like if this front end thing looks like shit, I want to like get that looking right and make sure I like the behavior there before we go and actually wire in real data, because I want to not have to debug the data layer and the front end experience at the same time. I want to like test and validate one piece at a time.
I also want to chime in on like one other point here. Like we're doing this live on the podcast. There's no way Dexter had time to read this as thoroughly as he would normally if he's coding. So like part of that means, well, if I haven't read everything super thoroughly, I need to be more rigorous about testing earlier rather than later, even more so than normal. So even though in like my example, I showed you that I went all the way through and like the plan just executed one way through. Yeah. What I had to do was I had to go ahead and actually read everything super meticulously. And you saw how many commits it took to actually get to the final point to make it work. Yeah. But it was very meticulous. Here, by moving the UI phase up and actually making sure that the database gets correctly done, we're just reducing the risk that any design decisions we made were going to be incorrect along the way. And again, there's no right or wrong answer. It's just a preference based on what tolerance you have for redoing work when something is incorrect.
Yeah, and we won't actually finish this today, unfortunately, because I know Vaibhav's got a hard stop. But the way I think about this is like you want to. Let me delete some of these things. Basically, like the more time you spend on the plan, chance you have to backtrack. The more time you spend on the like. So vertical is like the correctness of the plan, right? The more time you spend on it, the closer you can get it to like full one-shottable. But the idea is like there's some sweet spot where it's like, okay, if I can spend 10 minutes and get it 90% of the way there, then that's better than spending an hour to get it 99%. Because there still might be surprises. And at a certain point, it's easier to read the code and play with it than it is to like stare at a 1,000-line plan doc. And so like this is actually split up into a number of different probability curves, which is like, okay, what's the chance that you have to iterate on it live? That's the area below this curve. So that goes down the longer you do it. And then what's the chance I might have to like re-steer and restart the implementation? And what's the chance I might have to restart the design? And it's like at every phase, it's like the chance you will have to backtrack goes down the more time you spend on it. But you're never going to guarantee that you can one-shot it. And so there's this weird like optimization problem that I think is like just takes a lot of intuition of like how much time should you spend at any phase making sure that it's good versus like how much time will it waste if you have to backtrack? Yeah. Does that make sense?
Exactly. And then David, you're asking a really good question of like, are you asking anyone else on the team to review these docs? I know Dexter clearly said like if he had this question, he would have normally sent Kyle to go look at it. We kind of operate the same way as well, which is the way that we operate on our team is like by default we just trust individual developers to make good decisions. But that part of that making good decision is to recognize when something is complicated and to bring someone else into the fold as they need to. Because it's impossible for everyone to read everything; it's just not worth it. But for really complicated things, you want more people, the more relevant people reading it whenever possible.
Yeah, and it's optional in our process, but like I am incentivized to send Kyle this design discussion and have him review this and help me answer the questions because the alternative is I make the decision that he doesn't like, and then I go spend all this time building it and testing it and playing with it and exploring it in the how do I say this, like the implementation phase, and then by the time it gets to PR, it's like, oh no, this is all wrong. We can't make another endpoint because of some random electric SQL.
There's some reason like something Kyle's working on right now that's going to conflict with this.
That's going to conflict with this. So it's like basically everyone's like complaining about drowning in like AI developed PRs or like PRs written by people with AI that are slop. And like I actually don't think the problem is too many PRs. I think the problem is too many bad PRs, and like even a 500-line PR, like not a big one, if it needs 20% rework, that is like a huge like
it's a mental
and
tax.
emotional burden on both the submitter and the reviewer to go and give the feedback and coach the person and all this stuff. And so it's like, if you can maximize the amount of time when like I send Kyle this PR and he's like, yep, that's what I asked for. Yes, that's good. Yes, you've done that right. Because we aligned on a lower stakes doc that I'm not attached to yet because I haven't dumped all this time into making sure it's right and polishing it. That is hugely valuable, I think, to any software team.
It's the same reason that like, look, you focus more on the plan than you do on the code. You focus more on the plan than you focus more on the design discussion than you do on the plan.
Yep.
Bring people in earlier into the fold. That's the magic. Bring yourself in, bring the agent in, like spend more and more time earlier on the fold making good decisions. The better your decisions, the better your output. It's a direct one-to-one correlation there.
This was super fun, man. Thanks for joining. I think we shared some interesting lessons. Hopefully this didn't just feel like a Riptide demo and you learned a little bit more about how we think and how we build stuff internally. So thank you all. Vaibhav, any last thoughts, any big takeaways here?
No, for everyone interested, next week we're going to talk about how to do PI redaction and how to actually design a system both on the eval side and the code side to go build that out. Excited to share.
Awesome.